In the last section, we focused on going from numbers of moles to the number of atoms or molecules and back again. In this section, we'll be converting the moles into grams and grams into moles. And to do this, we're going to need molar mass. So molar mass is the mass of 1 mole of a substance. So since a mole is 6.02 times 10 to the 23rd atoms, it's the mass of 6.02 times 10 to the 23rd atoms of any element. Now, mostly we will be determining molar mass for compounds. And so there are 3 steps to use to calculate the molar mass of a compound. First, we'll want to obtain the molar mass of each element. And the molar mass is fairly easy to find. You'll see it underneath the symbol. So here's iron, here it's in the middle. The number at the top is the atomic number. It tells us how many protons there are. And it's a whole number. It never has any decimals. We don't have a partial proton. The number underneath, this 55.85, is the mass of 1 mole of iron. So if I have 6.02 times 10 to the 23rd atoms of iron, they will weigh 55.85 grams. So we obtain the molar mass of each element. We multiply the molar mass by the number of moles, and that's the subscript in our compound's formula. And then we calculate the molar mass by adding all those masses together. So let's see how this works. Let's start with iron oxide. First, we have 2 irons. That's what this subscript means. So we'll have 2, and then we'll need to multiply 2 times the molar mass of iron, which was 55.85 grams. And then we've got 3 oxygens. So we're going to add our 3 oxygens. And oxygen has a molar mass of, let's get it over here in the corner, 16.00. And we'll need to add those together. And we will get 159.7 grams per mole. So if I have a mole of iron oxide, it will weigh 159.7 grams. Now I want you to pause the video and do the next problem. All right, I'm assuming you've paused the video. We first need to look up the molar mass of potassium, and it's 39.10. We then notice that we've got 4 carbons, so we'll put a 4 and we multiply times the molar mass of carbon, which is 12.01. We have 5 hydrogens, so we'll need to put a 5 here and multiply times the molar mass of hydrogen. And then we've got 6 oxygens. So if you multiply and add all those up together, we should get 188.18. And this is grams in 1 mole. Now, sometimes we have to be a little careful. We had this, we went over this sort of when we talked about balancing equations. We have to make sure we count up all the atoms that are present. So here we've got 2 aluminums. Aluminum is 26.98. The next atom here is sulfur, And we have 3 sulfurs because everything on the outside of these brackets gets multiplied by this 3. So we have 3 sulfurs. Sulfur is here, just on the edge of your paper. Hopefully you can see that, 32.06. And then we've got oxygen. We have 4 times 3, so we're going to have 12 oxygens. So 12 times 16.00. If you do enough of these, you will memorize oxygen and carbon and some of the more common ones. And your answer will be 342.2. And this is grams per mole. Okay. So if I can count things by weighing. So if I go to the store and I want 1,000 jelly beans, the proprietor of the store is not going to count 1,000 jelly beans, not unless he just has lots and lots of time. Instead, what he's going to do is he's going to find the average mass of a single jelly bean. So 1 jelly bean, in this case, weighs 5 grams. So that's an equality. I'd like to have 1,000 jelly beans, and I want to know how much 1,000 jelly beans will weigh. So I'd like the mass, and for mass I'm going to put grams. I'm going to put the units that I'd like to have. So here's my problem. I want to convert 1,000 jelly beans into grams. Here's my equality. I've got 1 jelly bean is equal to 5 grams. So I can write my problem. 1,000 jelly beans. I'm going to use my equality. I want jelly beans to leave the equation, and I'd like to have my answer in grams. So I'm going to put my 5 grams on top because that's the units that I want at the end. And I'm going to put my 1 jelly bean in the bottom because those are the units that I want to have cancel and go away. And my answer here will be 5,000 grams. So the proprietor of the store is going to get out his scale and weigh out 5,000 grams to give me my 1,000 jelly beans. You do the same thing if you go to Tractor Supply. You can buy bolts that same way. So how does this apply to chemistry? What is the mass of 6.02 times 10 to the 23rd atoms of aluminum? Well, let's pull our periodic table out here so that we can see it. Aluminum is right here, so the blue pen. The molar mass of aluminum is 26.98 grams. A mole of aluminum weighs 26.98. So what is the mass of 4 moles of aluminum? Well, we're starting with 4 moles of aluminum. We'd like to convert our 4 moles into mass, which is grams. We can take this 26.98 and write an equality. We can say that 1 mole of aluminum is equal to, or weighs, 26.98 grams. Then we can write our problem out. Now we need to use our conversion statement, or use our equality to write a conversion statement that's going to give us grams. I'd like grams in my answer, so I'm going to put grams in the top here. 26.98 grams. I'm going to put 1 mole in the bottom, and that's of aluminum. The moles of aluminum are going to cancel out, and it's going to leave us with 4 times 26.98 divided by 1, and that gives us our numeric answer, 104.92. And the only units left here are grams. Moles canceled, so we're just left with grams. So if I want to convert 4 moles of aluminum into grams, it's 107.92. So if I'm doing an experiment and I need 4 moles, I can go to my scale and weigh it out, and then I'll have exactly 4 moles. So we can do the same thing when we do molecules. So here we have water, and we need to calculate the mass in grams for 0.225 moles of water. So we're starting with 0.225 moles, and this is of water, and we would like to have the mass, and that's going to be in grams. And we need to know how moles of water converts to grams of water, how they're related to one another. And they're related to one another through their molar masses. So we can take the molar mass of this is going to be, let me write out molar mass. This is what we're calculating. It's going to be 2 times the molar mass of hydrogen, which is here, 1.01, plus 1 oxygen, which is over here. You can't see it. It's still 16.00. It hasn't changed. And we get 18.02. So we found the molar mass of water. We can use that to write an equality. 1 mole of water is equal to 18.02 grams of water. Now we're ready to set up our problem. And I'll start with the blue, I think. 0.225 moles of water. Yeah, we're going to move this down a little bit. Didn't hardly leave myself room, but we'll squeeze it in here. We need to put moles in the bottom, so 1 mole of H2O. That's going to make those moles cancel. We've got moles in the top and moles in the bottom. And we've got 18.02 grams of water in the top. So we're going to take 0.225 moles, multiply it times 18.02, divide by 1, and we will get our 4.05 grams. Okay, so now let you work this one. Stop the tape. Calculate the mass in grams for 4.4 moles of carbon dioxide. I have to assume you have completed that. Let's first calculate the molar mass of carbon dioxide. So the molar mass of carbon dioxide is going to be equal to the mass of carbon, which is 12.01 grams, and 2 oxygens, 2 times 16. Remember, these numbers are coming from the periodic table, are 1 carbon or 2 oxygens. Add these together and we get 44.01 grams per mole. What we'd like to do, the conversion we're trying to accomplish here, is to take 4.40 moles of CO2 and we want to know the mass. And whenever they say mass, they're looking for grams. Our units here are going to be grams. And we don't know how many. But we do know that 1 mole of CO2 is equal to the molar mass that we just calculated. Okay? So we've got the number that we started with. We've got an equality that relates it to the number that we'd like to have. So if I've left myself enough room this time, we'll have 4.40 moles of CO2. Then we'll need to put in our conversion statement. We want our answer to have grams, so I'm going to put the 44.01 grams in the top. We want moles to cancel, so I'm going to put the moles in the bottom. And we get 4.04 times 44, and we end up with an answer of 193.6 grams. So if I'm doing an experiment and I need 4.4 moles of CO2, I can weigh it out, and that'll be 4.4 moles. So on the other problems, they gave us the number of moles and we figured out how many grams. This problem is just the reverse. They've given us the grams and asked us how many moles. We're still going to need to have the molar mass, though. So let's start by calculating that. The molar mass of ammonia is going to be the molar mass of nitrogen, which is 14.01, plus 3 times the molar mass of hydrogen, which is 1.01. And that will give us a molar mass of 1703. Looks like I used a more accurate for this when I did this, but this is a rounding error is the reason you're getting a different number there. Okay, so that's the molar mass, grams per mole. We're starting with 15 grams of ammonia. We'd like to know the moles of ammonia. We're going to use this molar mass to come up with an equality. 1 mole of ammonia is going to equal 17.03 grams of ammonia. So we'll start with our problem, 15 grams of ammonia. Then we need to write our conversion. In this case, I want to get rid of grams and I want my answer to have moles. So I'm going to put the moles in the top and we'll put grams in the bottom. That'll make my grams cancel, and I'll be left with moles as my answer, as my units for my answer. So I'll take 15 and divide by 17.03 and get 0.880 moles of NH3. So you're going to stop the tape and work this one. All right. The molar mass of aluminum oxide aluminum hydroxide will be aluminum, which is 26.98, we're going to have 3 oxygens, because remember that 3 gets distributed. So we have 3 oxygens, oxygen still 16.00, and we also have 3 hydrogens. This difference where sometimes I use 1.01 and now I'm using 1.08, it's just a rounding error. This is a little more accurate. But we end up with a molar mass of 78.02 grams per mole. That's our molar mass. So let's look at our problem. We're starting with 25 grams of our aluminum hydroxide. We'd like to know how many moles. We're going to use our molar mass to write an equality that we can use to make our conversion statements. So 1 mole of aluminum hydroxide is equal to 78.02 grams. So we write our problem out. We start with 25.05 grams of aluminum hydroxide. Then we use our conversion. We want grams to cancel, so grams is going to go in the bottom and our moles will go in the top. Take 25 times 1, divide by 78.02, and we should get, write it in blue, 0.321 moles of aluminum hydroxide. Now, you may think that you can save time by not going through all these steps. You get the molar mass, you know you're going to multiply or divide one or the other. It's very easy to get confused